So I wanted to actually talk a little bit about this exam that you took. I'm going to go through each question a little bit more slowly just to be clear. I want you to feel totally supported. Many of you are retaking this, and I just want to make it, I just want you to have every piece of information available. So, question number one, the order of magnitude of the weight of an apple is. So, I actually wanted to, it's a small thing, but I just kind of pull this up. So, this right here is a 100 gram mass. And you've kind of played with these in class. Just want to be clear, a 100 gram mass like this is a great thing to actually take a look at when we're looking at something like an apple. I'll just kind of sketch it here. So it's 100 grams. And the idea here is that 100 grams is 0.1 kilograms. So this little dude right here is about the mass of an apple. I think if you look it up online, an apple is more like 133 grams. So here's the point. 0.1 kilograms is a mass. The gravitational strength of the Earth is 10 meters per second squared. Whoops. Let me write it IB style. Or if you prefer, 10 newtons per kilogram. So when we actually get the weight, that's going to be 0.1 times 10, which is on the order of 1 newton. So really the key here is to kind of have an estimate by the weight. 10 to the negative fourth and 10 to the negative 2 newtons. Very, very small weights. And then 10 squared newtons, that's, I'd say that's around, it's just an estimate, around 5 pounds, 10 pounds. So around 5 pounds is what I'd say. So, and I can confirm that. So, which one of the following contains 3 fundamental units? Let's review our fundamental units. So, we have meters, kilograms, seconds, candela, Kelvin, ampere, I'm missing one more, and mole. And let's be clear on what these measure. So meters measure length, kilograms measures mass, seconds measure time, candela measures luminous intensity, Kelvin measures temperature, ampere measures electric current, and moles measures number of molecules. So keeping this in mind, we need these 3 fundamental units, so it's really a process of elimination. So anything that has Coulomb can be eliminated. Sorry, I'm on the verge of sneezing. Anything that has Coulomb can be eliminated. And newtons, so coulombs are amperes times seconds, which we'll learn later on. Newtons are kilograms meters squared per second squared. So that only leaves us choice C. Now, for number 3, we have a series of readings. And, even before I read this question, this is what I want to do right away. So I'm just going to use this color for before I read. I'm just going to note these values are close together. I would regard them as being precise. Okay? So that's the first thing that pops into my mind, and I haven't even read the question yet. So that's what it says. The reading of a constant potential difference is made by 4 times by a student. The readings are, great, you're given a number and a unit. The average readings do not take into account the 0 error on the voltmeter. So what this means is we now have an inaccuracy. So the average measurement of the potential difference is, and look, it's exactly what we're talking about, precise and accurate. So let's eliminate the not precise choices. Our choice is not accurate because of the zero error. Therefore, we are left with a precise, be clear on that. These two are wrong. However, we are inaccurate, which means this is not true, and so this is not true, but this is, and that leaves us with choice B. We have a precise reading, but not an accurate one. So that's questions 1 through 3 on the practice exam. And I'm going to take a look at the second page in the next video.